So today I'm going to do a very interesting problem using L'Hopital's principle. I don't know if I pronounced that right anyway. And in this case, I'm going to find limit as n approaching infinity of 1 minus 1 over n to the n. This looks a lot like the limit of n to the infinity of 1 plus 1 over n to the n. And we know that this is just e. Good guess. So in this case, I thought this will probably be equal to e to the negative 1. Or maybe it's negative e? I don't know. So let's figure this out. First of all, notice that if you plug in n equals infinity into the whole equation, you'll have 1 minus 1 over infinity, which in this case will look like 1 minus 0. And you have 1 to the infinity. And you have no idea how that is, so that's actually not how it looks like. And in this case, we'll have used the L'Hopital principle. But you say that, how? Because the L'Hopital principle will have a division in there first, and how can we rewrite this whole thing into a division? So first of all, let's say this whole thing is y. Then I'll do ln of both sides. So you have ln of y will be equals to ln of y minus y over n to the n. And this is really cool part is because of the property of ln, this is equals to n times ln to the 1 minus 1 over n to the n. So in this case, instead of finding the limit at n approaching infinity of y, I'm going to say I'm find the limit of n approaching infinity of ln of y, which is find the limit n approaching infinity of this, and find the limit n approaching infinity of this. So now you're trying to find the limit as n approaching infinity of n times ln of 1 minus 1 over n. And how are we doing that? Well, obviously, if you just plug in infinity, it's not going to work. So I'm going to do a forced division here, making this whole thing equals to ln of 1 minus 1 over n over 1 over n. Because in this case, divided by 1 over n is equals to the same as multiplied by n. And now I can use the L'Hopital's principle and take it to the derivative of both sides. In the bottom, since it's n to the negative 1, you have negative n to the negative 2. On the top, you have 1 over 1 minus 1 over n. Sounds complicated. And multiplied by the derivative ddn of 1 minus 1 over n, which in this case is only the ddn of 1 over n, which is negative 1 over n, which is n to the negative 2. This is just part of the chain rule. And notice something really interesting here, that n to the negative 2 cancels out with n to the negative 2 in the bottom. So you're left over with negative 1 over 1 minus 1 over n. And notice this is limit as n approaching infinity. Now you can just plug in infinity, the whole thing 1 over n as n goes to infinity goes to 0. So you'll have negative 1 over 1 minus 0, which is, not surprisingly, negative 1. Are we done yet? No, we're close. Since we're looking for since this answer is the limit as n approaching infinity of ln of y, which is negative 1. And in this case, since L of y is negative 1, so the limit as n approaching infinity of y will be e to the negative 1. Because ln is basically asking how many e you have in this case. And since you have negative 1 e, so it's e to the negative 1. And what's y? Remember, we say y here is y is the whole thing. So we have our answer now. Limit has n approaching infinity of 1 minus 1 to the n all over together to the n's power is e to the negative 1. Thanks for watching.